Hello friends, welcome to Dr. Sai Physiology Academy, Doper for short. This is the place where we'll make the learning of physiology easy, exciting, and effective. Thank you for joining me. And if you're new to this channel, you're especially welcome. And if you love the content that we share, kindly click the like button and also the subscribe button. Don't forget to turn on notifications so you don't get to miss any new content that will drop. Now let's get started. So today we are dealing with the mechanism of breathing. Okay, sometimes it's called the mechanics of breathing, or the mechanics of respiration, or the mechanism of respiration. So it's the same thing. We're talking about the same thing. So now look at the word mechanics. It's talking about mechanical events that enable you to inspire and expire. Breathing means inspiration and expiration, two events in the cycle. Okay, inspiration and expiration. So this thing is telling you the mechanical process and mechanism, what actually makes it possible for you to take in air and makes it possible for you to take out air. That's what this is all about, right? So I'm going to be dealing with it, so pay very close attention. It's very interesting. First of all, two physical laws. Remember that physiological processes are dictated by the laws of physics and chemistry. Okay? There are two physical laws you need to remind yourself of. And that is, one of them is flow. Principle of flow. Two equations. Flow is equal to change in pressure. Okay? All over resistance. This is very important. It's trying to talk about that how a fluid will flow from one point to the other depends on, is directly proportional to the pressure difference or pressure gradient. Are you getting it now? Pressure gradient between one point and another point. We can put it as point 1 P1 and point 2 P2. So the larger the difference, the faster the flow, either of air or liquid, of water or whatever liquid. Okay, so this is a very important equation. Keep in mind, we are more concerned with this one is not so. Okay, then the next law, physical law, that you need to be aware of, I'm sure you know that so much, Boyle's law. Boyle's law. And that is what? P is inversely proportional to V. This being what? Pressure. This what? Volume. Means that when in an enclosed space, okay? In an enclosed space, when the volume of an enclosed space increases, the pressure inside, we're talking about enclosed place because additional air is not being added. Do you understand? So you carry something like a balloon, okay? You've blown air into it and you tied it, and then what do? You try to reduce the volume by pressing the balloon. What do you think will happen? The pressure inside the balloon will increase. So decrease in volume leads to increase in pressure. Do you understand? So that's what happens. So these two laws. So an understanding of these two will help you understand the mechanism of breathing, which is very easy. Now, the 2 points as it relates to the respiratory system. Point 1 is the atmosphere. Atmosphere. Point 2 is what? The alveoli. Do you understand that? Atmospheric pressure, alveolar pressure. The pressure in the alveoli, in the lungs. Those are the 2 points that we are interested in. And we're going to see how the manipulation of the volume will help in the movement Okay, flow has to do with the movement of air. So we're going to be talking about that. Don't go anywhere after this break. All right, you're welcome back. Now, these are the 2 points. What happens is that for air to move into the lungs, atmospheric pressure needs to be higher than alveolar pressure. Are you getting it? Because pressure, the movement will go from where it is higher to where it is lower. Do you understand? So this atmospheric pressure needs to be higher than alveolar pressure so that it can move from here to here, which happens during inspiration. But you cannot change atmospheric pressure just like that. Okay? You can't change atmospheric pressure. You don't have control over that. So what needs to happen is that you need to change alveolar pressure. That means you need to reduce alveolar pressure so that this one will now be higher and air will now move from there inside. So the question you ask yourself, how do you reduce alveolar pressure? I'm sure you are getting the gist already. How do you reduce alveolar pressure? Remember the equation. Okay? So to reduce alveolar pressure, you need to increase alveolar volume. To reduce alveolar pressure, you need to increase alveolar volume. So how do you increase alveolar volume? Very easy, very straightforward. The thoracic cage, the lungs, they're surrounded by ribs. Okay? And attached to those ribs, we'll talk about the pump. Attached to those ribs are muscles that can contract and expand the ribs. Do you understand? Also, the diaphragm is one of those muscles that are attached to the ribs that can contract and draw down the ribs. Okay, so you have inspiratory muscles and you have expiratory muscles. So inspiratory muscles are muscles that increase the intrathoracic volume and also the lung volume, because the lungs, they are attached, not physically now, but we'll talk about that later. They are attached to the thoracic wall. Okay, they are attached to the thoracic wall. So when the volume increases, the ribs, the muscles drag the ribs to increase. The lungs also is stretched with it and it increases. So intraalveolar volume also increases. Do you understand? So you have 2 muscles that are responsible for inspiration. You have the diaphragm and you have the external intercostal muscles. Okay? They are responsible for what is known as quiet breathing. We also have forced breathing. We are breathing with more force. Okay, when you are doing exercise or you have respiratory problems, that's forced. So there are other extra muscles that are involved. Then you also have expiratory muscles. Okay, internal intercostal, the rectus abdominis, abdominal muscles. But those ones are for forced expiration, because expiration, very important for you to note, is a passive process, because the lungs is like a rubber band, it's elastic. You need force to stretch the rubber band, but you don't need force for the rubber band to go back to its original dimension, do you? No. So the same thing happens. You need these muscles to contract, to increase and stretch the lungs in order to increase its volume and decrease its pressure. But you don't need any force, any contraction of any expiratory muscles to return it back. It's called elastic recoil. Just note that. Okay? So what happens is that the diaphragm increases the vertical dimension of the thoracic cage. Okay? Upward. So it increases it like this. Okay, why the external intercostals increase the dimension anteroposteriorly, so it lengthens and widens, all leading to increase in intra-alveolar volume. Just know that. So what happens is that when you want to take in air, the diaphragm and external intercostals, they contract and they increase the volume of the alveolar, which now decreases its pressure. And because the pressure has been decreased in 0.2, okay, then our atmospheric pressure is now higher than it. So there will now be flow of air from atmosphere into the alveolar automatically. Once it has decreased, automatic inflow. That's what the mechanism of breathing is. Then when they stop contracting, elastic recoil will take it back and now reduce the volume back, which will now increase the pressure, and it will slightly become above this, and it will now go out. That is the mechanics or the mechanism of breathing. Are you getting it now? It's just a change in volume and pressure, and then pressure gradient flowing from where it's higher to where it is lower. Just for you to know what is now making this one lower, which we have explained. You can only change here, you cannot change the atmosphere. So if you reduce here, this one, you increase this one, it reduces, and then this one is now higher and it flows inside. That is the mechanism of breathing. Do you understand that now? It's very easy stuff, right? So I'm going to see you in the next video.